Okay, so they're giving us two matrices, A and B here, and they want us to multiply if possible. And basically, we're going to answer here: is it possible or is it not possible to multiply these matrices? What's the story? Well, let me give you all the rules for matrix multiplication. So remember, again, we're in this new world called matrices, right? Boxes with numbers in them. Math makes stuff up. They made up matrices because it would be useful. It is useful for many things in the real world. So they make it up and they make the rules in a way that's useful. So now we're going to we know how to add two matrices. We know how to subtract two matrices. We know how to multiply like a number by matrix. I think give us 7 out here. You know, you would just multiply all of them. But how do you actually multiply two matrices? Like, how do you take A times B? What is matrix A times matrix B? Now, you might be thinking, I would be thinking, well, you just do the same thing. Just go this times this, and this times this, and this times this, and that times that. Just like that. It's simple. Turns out, no, they didn't do it that way at all. They did this thing which is going to seem to you crazy when I show it to you. If you haven't already seen it before, you're going to think that is wacko. What in the world? Why did they come up with that? And you know what the answer is? What's the answer I always give about why math made up things like they did? Because they did. They made it up. They could have done it like this, but they made it up in this weird way. Why? Because it's actually useful that way for real life science problems and engineering and things. Anyway, so let's first learn how to do it. I'm going to do it by hand in this video, and then I'm going to show you with technology with both the TI calculator and with the GeoGebra website. And then we're going to do it every which way here. So, all right, first off, what is the size of matrix A? Remember, you go down and then across. So that's a 2 by 2. And the size for matrix B, go down and across, is also 2 by 2. Well, here's the deal. If the inside numbers must be equal to be able to multiply. In other words, you can't even multiply two matrices if their inside numbers, their inside dimensions of their sizes don't match. They've got to be equal, and they are. 2 equals 2. So our first answer is yes, it is possible. That's what we choose right here. It is possible to multiply these two matrices. Why? Not because they're the exact same size. You might say, oh, it's because you're saying they're exact same size. No, I'm not saying that at all. I'm saying when I did the size and got 2 by 2 and the size this one, the inside, this could have been 7 by 2 and 2 by 10, and it still would have been okay as long as the two inside numbers are equal. As long as the two, when you write out the dimensions of the size, which always goes down first, then across, down first, then across, as long as the two inside dimension numbers are equal, it's okay. They must be equal to be able to multiply. If they're different, if this was a 2 and this was a 3, you could not multiply those matrices. Right? So what am I saying? So I'm saying, for example, if you had 1, 2, 3, 4, and you had 5, 6, let's do this. Let's make it, and then 7, 8, 9, 10, 11, 12. Like that, both of them being a 3 by 2 and a 3 by 2. See how those inside numbers don't match? You couldn't multiply those. You think, you can't, they're the same size, right? Sometimes you cannot multiply same size matrices. I just scribbled that out real quick. I hope that's making sense, right? Did you see what I mean by the size on those things? I did it so fast, I probably muffed it. This is a 3 by 2, and this is a 3 by 2. They're both down, 3 down and 2 over, right? Well, their inside numbers are not equal, so you cannot multiply these guys. You think, well, yeah, you can just do it that times that. Nope, that's not right. That's not true. You just simply cannot multiply those two. So first off, are you seeing what I'm saying? Are you, as the old saying, are you smelling what I'm stepping in, as they say in the South, right? Are you tracking with me? Are you with me close? The inside dimension numbers must be equal. If they are, it's a green light, go. You can multiply them. If they're not, forget it. So even these two, which are actually identical size matrices, would end up having inside dimension numbers that are different, and they could not be multiplied. All right, I want to make sure I'm clear on that. We mean what we say, we're saying what we mean it. The inside numbers must be the same, which is not the same thing as saying the matrices have to be the same size. Sometimes the same size matrices can't even be multiplied, as I just showed you. All right, so this one's a yes, green light, go, do it. You can multiply these two matrices. Okay, great. So how do I do it? What exactly do I do? Well, that's where it gets really weird. Let me show you. So you take the first one on the left, and the second one on the right. Okay, and here's what you do. Weirdest thing in the whole world is you basically go, well, first off, let me tell you, the inside numbers must be equal. So that makes it okay. And then the outside numbers tell you, which is 2 by 2, that's, this 2 and this 2, that's the size of the answer, or the dimensions, I should say that's the dimensions. That's the dimensions of the answer matrix. The answer matrix is going to be a 2 by 2. Like that. The answer matrix is going to be a 2 by 2. It tells you that. So one more time, let me be really clear on this. When you're multiplying two matrices, you write out their dimensions, 2 by 2, 2 by 2 in this case. If the inside numbers match, it's a green light, go. And in that case, the outside numbers tell you the dimensions of the answer. The answer is going to be a 2 by 2. All right? Okay, so now so what is the actual answer? How do you do it? Well, here's what you do. You take your left hand, and it's got to go straight across, and your right's got to go down. And you just jump every time you switch. Here we go. -5 times -2. In fact, I probably, what if I should have left one room here? -5. Yeah, I should have probably. Okay. Oops, it's not what I wanted. Here we go. -5 times -2. And then he jumps to the next one and he jumps down. See, this guy's always moving across. This guy's always moving down. So this times this, and then they jump. This times this. Plus 0 times 2. Which ends up becoming I don't know, what is that number? 10 plus 0 is just 10. Do you see what I did there? So this one is always moving across. This one's always moving down. So I started with -5 and -2, right there. And then I jump to 0 and to 2. And they multiply and add those up. It's +10. Next, so notice that's the upper row, left column, upper left entry. And now I move this arrow over here. Tracking with me right down there. And again, I start -5. This is going to go left. This is going to go left on the same row again. Going to reuse the -5 and the 0. Why? Because I'm still in the top row. And this is going to go down. So here we go. -5 times 2. Write that in. And then he's going to jump. This guy is going to jump over, and this guy is going to jump down. 0 times -2. And so what is that? That's a -10, I think. And now we'll go down to we'll go across the bottom row, and this arrow will come back over here and start back over there. And we do it again. So I know this is weird. Isn't this weird? This is weird. We start right here. 1 times 2. Oh, no, that's not right. 1 times this guy, because this is moving down, right? So over here, you always start in the top. Start here or start there and go down. On the left matrix, you always start on the left and go across. So I'm starting here and here for the lower left, lower left. So 1 times -2. And then it moves to there and it moves to there. 1 times 2 plus 1 times 2. And that is a2 plus 2, that's 0. And then, now finally, I should say, we need the lower right. This is the lower row, but I got to move it over to the right. And you start up here, you start here, right? You always start on the left and you start on the top. So 1 times 2. And then you jump. Oops, didn't mean to do that. And you jump to there, and you jump down to there. 1 times -2 plus 1 times -2. And that's 2 minus 2, that's 0. And there we go. We have done it. We have multiplied matrix A and matrix B. And what did we do? We started by checking that the size was right. We checked with the size. We said it's the dimension. It's a 2 by 2 and a 2 by 2. The inside numbers have to be the same. Then it's a green light. Okay, it's possible. And the 2 outside dimensions are the dimensions of the answer matrix. We knew the answer was going to be a 2 by 2. So I put these 4 blanks. And then you multiply. You start up here, go crossed with your left matrix and down with your right matrix. You multiply, and then everybody jumps. Jump to the next one, jump to the next one, and then multiply those guys. Add them all up. That's 1 entry. And just keep going, entry by entry, like that. Now let's jump and let's put it in on the graphing calculator. So if you have a I'm going to show it on the TI-84. Here's a TI-84 graphing calculator. I'll show you the steps that you need to go through. I'll put the key press history over here. And we'll turn on the calculator. And you need to, first off, you need to put the matrices in the memory banks. Here's the matrix, that blue right there. It's above the x to the -1 key. So you hit second, x to the -1. And this is, you're in the matrix menu. That's that blue, you're calling on that blue matrix. So I'm in the matrix menu right now. And in the matrix menu, there's 3 submenus: names, which I'm on right now, math, and edit. You can move over. There's different math functions you can do. Go over to edit. There's different things there. So you can go back and forth between those different options. So what I'm going to do is I'm going to go over to edit because I want to edit. It's kind of like editing a word processing document. You're going to put in a matrix. You're going to put in a paper you're writing, put in a matrix. I'm going to hit enter. So I'm on edit A. Notice I'm going to hit enter. And it says, okay, what size is your matrix A? So I'm going to, matrix A was a 2 by 2, right? I'm going to go 2, enter, 2, enter. And look, it sets up a 2 by 2 for me. Now I'm going to put in the numbers that we had in the problem. For A, it was -5. See the negative? I used the negative at the bottom. The negative is different than the subtraction. It's a really common mistake. Does everybody see that? At the very bottom of the screen down here, there's a negative which has parentheses around it on the TI-84. That's different than the subtraction button. Negative is the sign that goes on one number all by itself. That's different than a subtraction, which goes between 2 numbers, right? The TI is very picky and gets all bent out of shape if you switch those up. It's not very user-friendly. The Casios are much more user-friendly. They don't care. But watch out with the TI. So -5, enter. So I just put a -5 in the upper left. And next one was a 0, enter. Next one was a 1, enter, 1, enter. So there we go. See how it's -5, 0, 1, 1. That was my matrix A. So now I'm going to go second, quit. I'm going to quit out of this. I'm done. And it's got it saved. Just like when you save a document, and then you quit back out of the program. That matrix A is now saved in the memory banks. How do you know what you didn't? I didn't click save it. No, I didn't. Every time you hit enter, it automatically saves, updates what you've done and saves it right then. So every time I hit enter, it was saving the matrix. So it's saved. It's good. Now put in the other one. Second matrix. I'm going to go down to B though. I'll push the down arrow, B, and go over to edit. I'm going to edit matrix. Oops, got to go back down again. Edit matrix B. See how it's got A as a 2x2? It's got it in its memory banks. I'm going to hit enter. I'm going to edit B. So it says matrix B. What size is B? Well, it's a 2x2. 2, enter, 2, enter. I'm going to go, okay, here it comes. It's going to be -2. The first, -2, enter. Regular 2, enter. Regular 2, enter. And -2, enter. So there's matrix B. So it's -2, 2, 2, -2. And again, I'm going to go second, quit. So it's got A and B stored in its memories. Now what do I'm going to do? Now I'm going to call them forth. I'm going to go back into the matrix menu a third time, but this time I'm going to name them. See, I'm on names. I'm not going to go over to edit. I'm on naming A. I'm just going to hit enter. Yeah, boom, it puts A on the main screen. I just named it, kind of like, you know, like in a magic spell or something, like Harry Potter movie or something, where you name it and it comes forth. I just named matrix A and it popped onto the main screen. Times, I'm going to go multiply. And then I'm going to go back to the matrix menu, and I'm going to go down to B, name B. Ready? B, come forth. Like a magic spell. There it is. A, so it's matrix A times matrix B, and then just hit enter. And there's the exact same answer we got. 10, -10, 0, 0. There's how you do it on a graphic calculator. A little bit easier once you get the hang of it. Now, last thing, I want to go to GeoGebra. So I'm on GeoGebra. You're seeing this on GeoGebra. First off, to put it in on GeoGebra, you got to do curly brackets like this. Curly bracket, -5, 0 for the first row. And then I'm going to go right arrow, comma, curly bracket, 1, 1, enter. And right away it says matrix 1, and boom, it's got matrix 1. And now I'm going to do it again. Double curly bracket, -2, 2, right arrow, comma, another curly bracket, 2, -2, enter. I don't know what happened. I'm going to delete that, and I'm going to say B equals, and I'm going to do that. Try it again. Maybe it'll take it better this time. -2, 2, comma, curly bracket, 2, -2, boom. Yeah, like that better. I don't know. Liked it better when I called it B. So I just want A equals B equals. So everybody see how I type those in with the curly brackets? Then you just go A times B. Boom. There it is. Same answer we got. I just did A times B with the shift 8, the asterisk. A times B, and it did it. It multiplied and got the same answer we got by hand and by TI-84 graphing calculator, 10 - 10, 0, 0. So there we go. 3 different ways, whatever way you would like to do it. Make sure you do know by hand though. There's some things you might think technology, we don't need by hand. Well, yeah, you do, because you have to be able to tell the calculator and computers what to do in different situations. So you do have to be able to do it by hand. You have to know how it's done by hand to be able to direct technology faithfully. So that is important. So make sure you do understand the by hand. And so there we go.